we have Manning's roughness coefficient. So that is why we are going to use Manning's equation. 1 by n r to the power 2 by 3 sb to the power half. Okay. Then you find out velocity. So here you can see area is b into y, 2 into 1.5, we got 3 meters square. Okay. Then we need to find out velocity. To find out velocity, we have used Manning's equation because in the question Manning's roughness coefficient is given. Okay. So bed slope here in this velocity equation, bed slope is given, that is 4 by 8,000. Okay. So n is also given, that is 0.012. Okay. What is not there? That is r, that is hydraulic radius. R is equal to nothing but area by weighted perimeter. So area also we have already calculated, that is 3 meters square. So what we need to calculate now, that is your weighted perimeter. Okay. So we all know weighted perimeter of a rectangular channel. You can see this diagram here. So weighted perimeter means till the level of water. So perimeter till the level of water. Okay. Not the whole channel. Okay. So we have to add y. Then we have to add the width of the channel. Then again we have to add depth of flow. That is y. Okay. So that is why weighted perimeter is b plus twice y for a rectangular channel. Okay. So we have add 2, b is equal to 2 meter is already given. In addition to that, 2 multiplied by y. That is we have add 2 times of y. So that is why we have taken twice y. Okay. 2 multiplied by 1.5. So weighted perimeter you are going to get is 5 meter. Okay. Then you substitute in this equation and find out the velocity. And see, you get the discharge is almost 4 meter cube per second. Okay. Use your calculator and try to find out this result for discharge. Okay. So here you see, or in Manning's equation, n value is already given. R is a by p and SB equal to 4 by 8,000. Okay. You can write 4 by 8,000 or you can also write 1 by 2,000. It's up to you. Okay. 4 by 8,000 or you can write 1 by 2,000. So area is 3 meters square and weighted perimeter we got 5. Okay. Substitute here, use your calculator, find out the velocity, and then you multiply it with area and find out the discharge. You will get approximately 4 meter cube per second. This time we need to find out bed slope, SB. Okay. Okay, so we are going to proceed to the next numerical. Okay. Second numerical. Find this slope of the bed. Okay. So this time we need to find out bed slope, SB. Okay. We need to find out the bed slope. Okay. Then what is given? Again, it is given as a rectangular channel. Okay. So first it says we need to find out the bed slope, or you can say slope of the channel of a rectangular channel. Okay. This next second thing is given is rectangular channel. Then what is given? The width of the channel is 2 meter. That is also given. Okay. So here it is not visible, is nothing but when water depth is 2 meter. Okay, water depth is also given, that is 2 meter. Okay, and this is end. Okay, find the slope of the bed of a rectangular channel of width 2 meter when the water depth is 2 meter and the rate of flow is nothing but your discharge. Okay, is given as 20 meter cube per second, and we have Sages constant that is equal to 50. C equal to 50. Okay, so what is given? Width of the channel is given. The channel is rectangular channel. Width of the channel is given 2 meter. Depth of flow is also given 2 meter. Discharge is also given 20 meter cube per second, and Sages constant is also given 50 meter. Sorry, 50. We don't have any unit for Sages constant. Okay, it's 50. So again, we need to find out the area. Again, we need to find out the area like the previous case. Area equal to V into Y. As in the question is given, it is a rectangular channel. So area is 4 meter square. Okay. So discharge equal to area multiplied by velocity. Okay. Discharge is given this time. Okay. 20 meter cube per second. Area we have already calculated, that is 4. In velocity, as Sages constant is given, so we are going to use Sages equation. Okay, we are going to use Sages equation as Sages constant is given. So we are going to use Sages constant. Sages constant multiplied by R into S. So if you see in this question, SB we need to calculate. Okay, we need to find out SB, that is bed slope. C is given 50, R, then we need to find out R. R equal to area by weighted perimeter. Okay, area we have already calculated 4 meter square. Then we need to find out the weighted perimeter. Okay, so definitely it will be B plus twice Y, as given this channel is rectangular. Okay, so we have calculated the weighted perimeter and found it to be 6 meter. So area will be 4 by 6. Okay, then you substitute in the value of R as 4 by 6, C equal to 50, and you see you have one equation and one unknown. So you try to find out the slope and see how much you got. Okay, here you can see R equal to A by B, that's 4 by 6. You can also write 2 by 3. Okay, then we have calculated velocity. You can directly use those equation, or you can also use, or you can also solve in this way. Okay, no issue. That is Q equal to area multiplied by velocity. So velocity equal to Q by area. The answer you are going to get the same. Okay, Q by area equal to velocity. So discharge is given 20, area is already we have calculated, that is 4. Okay, so it is 5. Velocity is 5 meter per second. Okay, and then you can use this equation and find out the bed slope. Okay, you will get this value. Okay, try to find out the slope and see if you are getting the same or not. Okay, And if you have any doubts regarding this, you can ask me. Okay. So you are getting the value 3 by 2. You can also write 1 in 200 divided by 3. Okay. If you divide this, you will get one. How much you are going to get? 300 divided by. Next numerical. Okay. Number 3. So find the discharge. We need to find out the discharge of a trapezoidal channel. So this time our channel section is trapezoidal. Okay. And then given is width is 8 meter, side slope, okay, is 1 horizontal is to 3 vertical. Next, depth of flow is given 2 meter, sorry, 2.4 meter, and the bed slope, that is your SB. Okay, bed slope is given 1 in 4,000, and Sages constant is given is 50. Okay, Sages constant is given. So what is given? Trapezoidal channel. Width of the channel is 8 meter. Side slope is 1 horizontal is 3 vertical. Depth of flow is 2.4 meter. And bed slope is given 1 in 4,000. Okay. And the last it's given C equal to 50. And we need to find out the discharge. Q equal to. What will be the discharge? Okay. So this is your trapezoidal channel. Okay. So what is given here? Side slope is given. Okay. Width of the channel is given 8 meter. Okay. And depth of flow is given 2.4 meter. Now, first of all, we need to find out the area. So to find out the area of a trapezoidal section, we have to do sum of the parallel sides. So in this trapezoidal section, we have two parallel sides. One is your top width of the channel and one is your bottom width of the channel. See, when we consider rectangular channel, the calculation is much simpler than the other channel section because the top width and bottom width in a rectangular channel is same. Okay. Whereas if you consider in trapezoidal channel, your bottom width and top width are not same. Okay. Your top width and bottom width are not same. Okay. So in this case, we have two parallel sides. One your bottom width, that is your B, and one is your top width. So area of a trapezoidal is nothing but sum of the parallel sides divided by 2 multiplied by the vertical distance. That is vertical distance between your top width and bottom width. That is nothing but your depth of flow in this case. Okay. So this is your area expression for trapezoidal section. Bottom width addition top width divided by 2 multiplied by the depth of flow. Okay. So now bottom width is given, that is your 8 meter. Okay. In this question, your bottom width is 8 meter. Depth of flow is also given, that is 2.4 meter. We need to find out the top width to calculate area. So first we need to calculate top width. Our first intention is to find out top width. Okay. So to calculate top width is from here to here. Okay. So we have two extra portion than the bottom of the width. This middle part, we can say this is the bottom width. Okay, from here to here. Okay. In addition to the bottom width, we have another two portion. That is one here, another one is here. Okay. So first, our intention is to find out this portion. Okay. So why it is called Z Y? Okay. Suppose this is our depth of flow from here to here. Okay. And we have considered that is Y. Okay. And side slope is nothing but your 1 is to Z. Okay. Let us see, when we have considered side slope, we have one vertical distance and one horizontal distance. That is, one vertical is equal to Z horizontal. Okay. We have considered, in general, we always considered our side slope is 1 is to Z. Okay. So 1 is to Z. One vertical is to Z horizontal. That means this is your vertical, this is your vertical, and this is your horizontal. This is your Z. Okay. And this is your vertical. We have considered one vertical, Z horizontal. So we can write one vertical is equal to Z horizontal. So now see, for this portion, we have a vertical of Y. Okay. If one vertical is equal to Z horizontal, so what will be the value for Y vertical? It is nothing but your ZY horizontal. Okay. These things you have already studied in third semester. Okay. We are just brushing up. Okay. How to find out this slope. Okay. Or you can say this portion. So that is why, see here, if you see, this is our horizontal distance. Okay. This is our horizontal distance. This is our horizontal distance. This is our horizontal distance. Okay. And this is our vertical distance. If we consider this is the bottom of the bed, bottom of the channel, so this is our vertical distance. So the slope is one vertical is equal to Z horizontal. Then what will be the horizontal distance for Y vertical? Okay, we have to think like that. What will be the horizontal when your vertical is Y? Okay, if for one is Z, for Y it will be ZY. ZY horizontal. Suppose now in our case, what is the slope is given? One horizontal is to three vertical. In this question, it's given one horizontal, that is one horizontal is equal to three vertical. Okay. So we all know one vertical is equal to Z horizontal. Okay. And Y vertical is equal to Z Z multiplied by Y horizontal. Okay. So definitely we can also write in a reverse way. Three vertical is equal to one horizontal. Okay. So one vertical is equal to 1 by 3 horizontal. Okay. So we will get this thing. Okay. One vertical equal to Z horizontal. So in our case, our Z is equal to 1 by 3. Okay. In our case, if you compare both the equation here, this is your general expression and this is our present question. Okay. So if you see, our Z value is nothing but 1 by 3 in this numerical. Okay. For this numerical, our Z value is 1 by 3. Okay. So this distance is your ZY. ZY. So Z is 1 by 3 and y value is already known to us. It's given, that is your 2.4. So if you multiply this two, you will get this portion. Okay, you will get this portion. Okay, if you multiply these two, you will get this portion. In trapezoidal, if side slope for both the side is same, then this two portion is also same. Okay, if you find one, you need not to find the other one again. Okay, you just multiply the two. Okay, this is the bottom of the channel. So these things we have already find out. That is your 1 by 3 multiplied by 2.4. That is your zy. Is nothing but you will get 0.8 meter. Okay. So now our intention is to find out the top width. Okay. Top width will be this portion, that is 0.8. Then in middle we have width of the channel or bottom width of the channel, that is your b plus 0.8 again. Okay. This portion. So how much you are going to get? This is 8 meter, so it will be 9.6 our top width meter. 9.6 meter. Okay. So that is why in area equation we have 9.6 plus 8 divided by 2 multiplied by the vertical distance between the two lines. Okay. That is our y. So you will get the area is 21.12 meter square. Okay. So this is how you can find out the area of a trapezoidal channel. Okay. Definitely to find out the discharge. In this question, we need to find out discharge. Discharge is nothing but area into velocity. Area multiplied by velocity. So area we have already calculated. Now we need to find out velocity. As Sage's constant is given, so we are going to use Sage's equation. R into S. Okay. So to find out R again, area by weighted perimeter. Okay. So area we have already calculated. Now the next thing, we need to find out the weighted perimeter of a trapezoidal channel. Okay. So when we find out trapezoidal channel, weighted perimeter of a trapezoidal channel, we have to consider this side, then the bottom of the channel, and the side of the channel till the water level. Okay. This will be your weighted perimeter. Okay. So again, this portion is a right angle triangle. Okay. This portion is a right angle triangle where this length is given, that is 2.4 meter. This we have calculated 0.8 meter. Okay. And this we need to find out this portion. We need to find out. So we are going to use Pythagoras theorem to find out the side of the channel. Okay. Using the Pythagoras theorem. So that is why with the perimeter we need to find out. We have to add b. In addition, we have to take the both the side. Okay. And both the side will be same as other parameters are same. Okay. So that's why we have multiplied by 2, and then we have used Pythagoras theorem here, okay, for right angle triangle. Okay. Square root of square of other two sides, that is 0.8 whole square plus 2.4 whole square. This thing you have, okay. We have already did lots of numericals related to Pythagoras theorem in your 10th or 9th standard. Okay. So using Pythagoras theorem, we directly find out the weighted perimeter. Okay. Once you calculated weighted perimeter, find out the R value. R equal to A by P. Okay. And then you use Sage's equation. Okay, r is nothing but a by p. Slope is already given 1 by 4000. Okay, find out the velocity by using Sage's equation. Sage's constant is given. R is nothing but a by p, and rate slope is already given 1 by 4000. Okay, see, you are getting the velocity same as 1 meter per second. Okay, and then you substitute in this equation and you can find out the discharge. Okay, try to calculate and see you are getting the same value or not. If you have any doubt, how much you got? They all are requested to give you attendance in the chat box. Okay, we will continue in the next class. Okay. 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 We will continue in the next topic in the next class. Okay. That is in that is on Wednesday. I think in second period. Okay. Thank you all.